Hi guys, today we'll solve day 7 of Advent of Code, and let's see. So over here we get calibration equations, fancy word. So we get test values on the left, and we get a number or an amount of other numbers without operators, okay? So we have to find out in which way we are putting add and multiply operators between these numbers, so we get back the test value, right? For example, 190. If we put over here a plus, we would have 29, right? Not the test value. But if we put a multiply, then we will have 190. Okay? And then in the end, we only want the equations which gave us back the test value, which were correct, right? And then we just have to sum these up. So of all these, 3 of them were right, okay? And then we just sum up the test values, okay? And this is the real input. And let's start. So first of all, I will grab this. I will copy the test input like this, okay? Now, what we want to do first is we want to parse this. And for that, I will create a parse function. Today we won't create any structs because this exercise doesn't need it. Let's do our puzzle. And we want to get back a vector of tuples with U64, and inside also another vector with U64. Okay, so what I want to achieve is, if we have over here this line, I want to put all of this in a vector, right? And then here we have tuples, right? Or here we have a tuple. So this will be the test value. This is the first element in the tuple, and the second element in the tuple will be another vector with the numbers. Okay? So let's see. We take the input or the puzzle, we iterate over the lines, and then let's do filter map. So line, and let's see. So first of all, I want to split the line. Let's do split once, because then we will get back a tuple, right? So we have then a tuple. We split it over this, right? So we have a tuple with this, and we have a tuple with this, okay? So the test value, we trim it, parse it, and okay. And because we are doing here filter map, we can use the question mark operator. And you know, usually I will trim, but it's not necessary here because we know the input is always properly formatted, right? And then the numbers, so we want to parse these numbers too. So let's split on white space. Why isn't this? Okay, let's continue. We do filter map. Okay, we do filter map over num, and each number we will parse, and then we collect that. Okay, then all we do is we return test and nums. And of course, at the end we have to collect it once more, right? So we collected the inner vector with the parse numbers, and then we return a tuple with the test value U64 and the vector of U64's, the nums, and then we collect it into another vector, right? Okay, so then what we can do is we can parse. So we parse the test, and then we can iterate, and we want to do filter. So we get test and none, right? Because parse test will return a vector of tuples, right? So we can match on the tuple directly. And then we will create a function called solve. We will put the test and number, right? Then we map, because we only want the test. We need the numbers. We return test, and then we sum, right? That's all. And in the end, we return that as an option type, like this. Okay. Now let's create the solve function. We said we want test, which is new 64, and numbers, which is, let's take a slice because we don't modify anything. And this should return Boolean, okay? But I want to show you first what I will be doing. So we have the test value and the vector of numbers, right? Now what we will be doing is we create another vector taking the first value, okay? Taking the first value, 81, okay? Then we take the second number and we add and multiply, right? So adding is 121, and let me take over here, let's do it like that. Let's see, multiplying 81 by 40 will be 3240, right? So we have added and multiplied this over here. And then we take this number and again we add and multiply with any of these numbers, right? Adding and multiplying. So adding this to this, 108, then multiplying 2187, then this two, so we have 148 and multiplying 3267. As you can see, this is the test value. Then taking this over here, we add to it. This would exactly be the test value again, so we found it 2 times, and multiplying like this, right? Sorry for my handwriting. Like this, right? And then all we do is we take this vector and we see, does this vector contain the test value number, right? If it does, then that means we have a correct equation and we can sum it with the other correct equations, right? So let's see. So first of all, we take the numbers, we iterate over them, we skip the first number, right? And then we fold. And fold is basically like reduce, but we start with a custom starting point, right? So in reduce, it always starts with 0, but we want here to start with a vector. And we put in this vector the first element in the nums vector, right? Which will be the start. Then we have the accumulator, let's call this results, and the element we are iterating over, like this. And then we iterate over the results vector, right? So this is basically this vector I've drawn over here, holding the results of the equations, right? So results, iter, and then let's do flat map. And then all we do is we return a vector with the result of res plus number and res times number, right? What I've explained before. And then collect. And then in the end, all we do is we check, does this vector contain the test value, right? Contains. Like this, right? And we use flat map here just because we are returning another vector, right? We don't want to nest. We don't want to have this results vector 81 and then another with this 121 and another, and then in the next it will be another, right? We don't want nested vectors. That's why we use flat map. Okay, and let's use 64 because the numbers get pretty big. The 64, right? And so we get back here, when we call dissolve, we get back a boolean. So we only take the ones returning true. Then we just take from the valid ones the test, right? And we sum it up. Let's see. Cargo solve 7 release. Okay, nice. Submit that. Submit part 1. Oh my god, I forgot again. This is getting annoying. Input. And okay, let's submit. That's the right answer. Nice. And now part 2. So part 2 is basically exactly the same like part 1, except we add another operator. So we have add, multiply, and the new operator will be concatenation. Okay. So this time, if we have, for example, this test value, and we have these two numbers, we can concat these. So 15 and 6 concated will be 156, right? Which would make this valid. And over here too, right? We have these numbers and we can then concat these two in the middle, right? So we have 86 and we multiply by 6 and 15 and we get the right number. Okay. Now, I want to actually show what we will be doing. Okay, so the logic is actually the same. So we take the first number, 15, and then we iterate over the rest. And in each iteration, we add. So we add, we multiply, and now we also do concatenation, right? These three operations. So 6 plus 15. 21, then 90 multiplication, and now concatenation would be 156, right? So 15 concatenated with 6 is 156, which is the test value, right? And when I first solved this, I did it with string formatting, and I will show you this way, and then I will show you a more mathematical way. Okay? Let's see. So, the first thing I want to do, because we are over here using the same logic, basically. So I don't want to rewrite everything. So what I want to do is create an enum, let's say concat on or off. Okay, that's all. And then over here, we are basically doing the same thing. we will rewrite that in the end, but for now let's keep it like this. And now in the solve function, we want to also add the mode concat on in the second part, and in the first part concat off. Okay, this is just so we don't write everything again. So in the solve function we get the mode, and this is of type concat. Okay, and yeah, the rest is basically the same. So all we do now is basically just concatenating. Okay, so we have over here the res plus num and res times num, right? As I've showed you, we iterate over the results, and from the numbers, for each number we multiply, we add, and now we also concatenate. So that means, let's over here first do it like this. So we match the mode first, right? So if we have concat off, this will be the first quiz, so we return what we had, right? Like this, concat off, like this. Now if we pass concat on, right, we also have to check for concatenation. So what we'll do is exactly like before, we add, we multiply every result with the numbers, and then we will do a concatenation. So first let's do it with a string. So you can use the format macro for that, and we just take res and num, right? And then of course we have to parse it, use 64 and unwrap, because this returns an option, right? So that's basically it. We just concatenate like that, parse, and add it also to the results vector. Okay, and then over here we have to return U64, right? And I see I didn't have taken the test input. So like this. So if we now check, I didn't pass the test input. Okay, this is correct. Now, as you can see, we have used here string formatting, and this is a way, but it's not the most efficient way. And there is actually a mathematical way of doing that a lot faster, and I want to show you what I mean. So we want to concatenate these two numbers, right? So again, these should then become 156. How would we do that? So the first thing is we take the second number, right? And we want to find out how many digits are in the second number. So in this case, there is one digit. How can we find that out programmatically? So we take this 6, and then we do log 10, right? So 6 log 10. Six, let's import math, log 10, 6, right? This would be this number over here. Now what we have to do is, let's say 0.7. We have to floor this number, meaning the number becomes 0, 0, and then we are adding 1. So we get the amount of digits, right? I'll give you another example. I will give you another example. 1000 has 4 digits, right? So 1000 log 10. This is an easy example. And by the way, if you don't know what log10 is, so log10 is basically the same as saying 10 to the power of what will be 1000, right? 10 to the power of what? In this case 3, right? 10 to the power of 3, meaning 10 times 10 times 10 will be 1000. Excuse me. This will be 3, okay? 1000 log 10 will be 3. And then we add 1 and we have 4, meaning 4 digits, all right? And then, so we know, for example, 6 has 1 digit, and then we multiply 15 times 10 and the number of digits on the second number, right? 10 to the power of 1, and this would then be 150, okay? And then we can just add 6, and we have 156, all right? Let's take another example. Let's say 20 concat 24, right? So we take this log 10 and let's see, math log 10 24, right? So we floor this, meaning we get 1, and then adding 1 will be 2, right? So we have 2 digits. And then we take this times 10 to the power of 2, right? This case 2, because we have 2 digits, and this will be 100, so we will have 2000, and we add 24, right? So we get 2024, okay? And this is the way of doing that. So for that, we delete that, and we can call the concat function and passing res and num, okay? And let's create that. Concat, we take A, U64, B, U64, and return a U64. Now, we want to find out the length of B, the amount of digits, right? So B as F64, and we have to use here F64 because the log10 function over here, let me show you, is implemented only for F64, right? So we log10, we floor, then we have to pass it back to an U32, I will show you in a minute why, and we add 1, as I've showed you. And then we take the first number and we multiply it by 10 of type U64 to the power of B length, and we add B, right? And I cast it here U32 because the power method over here expects an U32 as an exponent, right? So we have successfully concatenated the two values. Let's see if this is still working. And this is still correct. Now the last step is just formatting the code a little bit. So we have this, this is all right. But you can see over here that we basically have repeated ourselves, right? The only real difference is the mode, right? The concat. One is off and one is on. So what we can do is, let's create a run function. So fn run, we take the puzzle as input, and we take a mode, right, of type concat. Let's put it below concat, actually. Doesn't matter, but like that. And then we return an option U64, because this is what we have to return, right? And then all we have to do is just taking this part over here, 8, like this, okay? Now, puzzle, like this. And we have to pass over here the mode. Okay? And then all we can do is over here, run with the input And in the first quiz, we want concat off. And in the second one, we want concat on, right? So mode, and let's do here a reference. We don't modify anything, right? So we have successfully formatted the code and make it more readable and more concise. Okay, let's see if the second one is passing. All right, see you in the next one.